Namaste children, welcome to today's class. So today we are going to discuss about the chapter number 15, Introduction to Graphs. So you are already familiar with these graphs in data handling chapter like bar graph, histogram and pie graph or pie chart. So in addition to this, in this chapter we are going to discuss about the line graph and linear graph. Line graph and linear graph. Now, introduction of this chapter. Have you seen graphs in the newspapers, television, magazines, books, etc.? The purpose of the graph is how to show the numerical facts in visual form so that they can be understood quickly, easily and clearly. So we might have seen the different graphs in the newspapers, televisions, magazines, even in the books. What is the purpose of making the graphs? We can understand the numerical graphs, numerical facts, that is the numbers, very easily, clearly and quickly. Thus, graphs are visual representations of the data collected. Data can be presented in the form of a table. However, a graphical representation is easier to understand. This is true in particular when there is a trend or comparison to be shown. We have already seen some graphs. Let us quickly recall here them. So what we call these graphs are known as a visual representation of the data collected, and we can represent the data in the form of a table. Then we can understand easily from the graphical representation. So in the previous class, that is chapter 5 we have the data handling is there. In that we have studied some of the graphs like bar graph, histogram and pie chart or pie graph. A bar graph is used to show comparison among categories. It may consist of two or more parallel or vertical, horizontal bars, rectangles. So what is a bar graph? Representation of data in the form of rectangles or bars. It may be in the form of horizontal or it may be in the form of vertical also we can use. See here, the bar graph in figure 15.1 shows Anu's mathematics marks in 3 terminal examinations, term 1, term 2, term 3 like this. It helps you to compare her performance easily. She has shown good progress. See bar graph. What we will do the bar graph? On one axis, that is horizontal line and vertical line, we have 2 lines are there, and on horizontal line we will represent the terms, first term, second term and third term. Marks are represented in the vertical line like 10, 20, 30, 40 and 50. The scale here it is, you see 2 boxes are there. 2 centimeters is equals to 10 marks or 1 centimeter is equals to 5 marks. Here you see. Now this will give you what? The bar graph about the marks scored by a girl called Anu in mathematics exam in the 3 terms. First term she scored 25 marks, second term she scored 30 marks and third term she scored 45 marks. Bar graphs can also have double bars as shown in figure 15.2. This graph is a comparative account of sales in rupees of various fruits over a 2-day period. How is figure 15.2 different from 15.1? Discuss with your Yes, this is figure 15.2. Here on the horizontal line we have mango, apple, orange, papaya, banana, different kinds of fruits, and sales in kgs on the vertical line 0, 5, 10, 15, 20, 25, 30, 35, 40 kgs. This shaded figure will give you the sales on Monday, and the other one it is there, the thin, will give you the sales in the Tuesday. So mango on Tuesday it is 17.5 kgs were sold, and on mangoes on Tuesday it is 22.5 kgs were sold. Like this we can compare the sales of different kinds of fruits on Monday and Tuesday. So this is a double bar graph, and similarly apple, you see on Monday 7.5 apple means roundly it is approximately it is 8 apples were sold, and 10 apples were sold on Tuesday. So this is the data which you will get it from the double bar graph. So the other bar graph which we have studied, it is a pie graph or a circle graph. A pie graph is used to compare parts of a whole. The circle represents the whole. Figure 15.3 is a pie graph. It shows the percentage of viewers watching different types of TV channels. The different types of TV channels are entertainment channels, sports channels, news channels, informative channels. So 50% of the people are watching entertainment channels, 25% of the people are watching sports channels, 15% of the students or the people are watching news channels, the rest 10% is informative channels. So here we will use these sectors by finding the central angle. So we have covered already in class 8 chapter number 5. The last one, it is histogram. A histogram is also a bar graph that shows the data in intervals. It has adjacent bars over the intervals. So histogram is also a bar graph, but there is a difference between the bar graph and the histogram. In bar graph we will find the width gaps between two bars, but in histogram there is no gap between any two adjacent bars. So here we have one histogram is there. You see here, this is weights of some persons. The table is given here. The histogram in 15.4 figure illustrates the distribution of weights in cases of 40 persons in a locality. Weights in cases 40 to 45, 45 to 50, 50 to 55, 55 to 60, 60 to 65, a number of persons 4, 12, 13, 6 and 5. So how do we draw this histogram? So we will draw one horizontal line, and that we will take weight in cases and the number of persons on the vertical line, which is known as the x-axis. You see here a zigzagged line is there. On the horizontal line we have a zigzagged line. It represents this. We use this a zigzagged line has been used along horizontal line to indicate that we are not showing numbers between 0 and 40. Here the scale is 5 kgs is there, but in the first figure we see here 0 to 40. So the zigzag line will represent the values from 0 to 40. So there are no gaps between the bars in the histogram, whereas we will find the gap between the bars in the bar graph. The last one, it is a line graph, which we are going to discuss. So a line graph displays data that changes continuously over periods of time. So here we have a line graph is there. So in line graph we will call the horizontal line called as the x-axis, and the vertical line is labeled as the y-axis. Vertical line is known as y-axis and the horizontal line is known as the x-axis. In a line graph, what we will do? We will represent the values in the form of points. Then we will join these points to get the line segments. That graph, which is formed by joining the points in the order, is known as a line graph. Yes, here we have a line graph of one girl who is suffering from fever. Her body temperature was recorded by the doctor at different time periods like 6 a.m., 10 a.m., 2 p.m. and 6 p.m. 6 a.m. her temperature is 37 degrees Celsius. 10 a.m. it is 40 degrees Celsius. So it is increased 3 degrees Celsius. Then at 2 p.m. it is 38 degrees Celsius, and at 6 p.m. it is 35 degrees Celsius. So the temperatures are taken on the a vertical line with a zigzagged line. Zigzagged line is there, that is from 0 to 30, and on x-axis, that is the horizontal line, time is represented 6 a.m., 10 a.m., 2 p.m. and 6 p.m. So we will find here some dots are there. Now these dots are joined with line segments, and we got a graph. That graph is known as line graph. See, each piece of data is shown by a point on the square grid. So the data is represented in the form of points, and these points are then connected by line segments. The result is a line graph. So what is the line graph? Here it is. The line graph is formed by joining the points. What these points will represent? These points will represent the data of the data of the given data. So when we join these points, we'll get the line graph. So on the line graph, we'll use the x-axis as the horizontal line and the y-axis as the vertical line. So what we will do in the line graph? We will represent the data in the form of points, and then we will join these points in the order. We will get the line graph. Clear, children? Now we understand how to draw the line graph. So here in exercise number 15.1, some line graphs are given. Based on that line graphs, you should answer the questions. The first question: the following graph shows the temperature of a patient in a hospital recorded every hour. So what this graph shows? It shows the temperature of a patient in a hospital recorded every hour. What was the patient's temperature at 1 p.m.? When was the patient's temperature is 38.5 degrees Celsius? First you observe clearly the graph. You see here on the x-axis, that is the horizontal line, we have time is there: 9 a.m., 10 a.m., 11 a.m., 12 a.m., 1 p.m., 2 p.m. and 3 p.m. Between 9 a.m. and 12 a.m. we have one small line is there that will represent what? Half of the time, that is half an hour. It will be 9:30 a.m. Similarly from 10 a.m. to 11 a.m. So again we have one line is there that represents 10:30 a.m. Then 11:30 a.m., 12:30 p.m., 1:30 p.m., 2:30 p.m. Similarly, on the horizontal line, the temperature is expressed in degrees Celsius. So here we have a zigzag line is there, which represents the values from 0 to 34 degrees. So 34 degrees, 35 degrees, 36 degrees, 37 degrees, 38 and 39 degrees is there. So the scale on x-axis it is 2 centimeters, it is 1 hour, and on y-axis it is 2 centimeters. 2 square grids will give you what it is? 1 degree Celsius. Now the temperature at 9 a.m. it is between 35 and 36, exactly half. So it will be 35.5 degrees Celsius. On 10 a.m. it is 36 degrees Celsius, and at 11 a.m. it is 39 degrees Celsius, and at 12 noon it is between 38 and 39, which is 38.5 degrees Celsius, and at 1 p.m. it is between 36 and 37, which is 36.5 degrees Celsius, and at 2 p.m. it is at the same temperature, 36.5 degrees Celsius, and at 3 p.m. it is 37 degrees Celsius. This is slowly a temperature is increased. See, from 9 to 10 we will find increase in the temperature. Similarly from 10 to 11 we find increase in the temperature. From 11 to 12 to 1 p.m. there is a downfall in the temperature, and from 1 to 2 constant temperature is there. Again from 2 to 3 p.m. there is increase in the temperature. Now based on this bar graph, answer the following questions. The first question, what was the patient's temperature at 1 p.m.? So you observe the time 1 p.m. on the x-axis, which is 1 p.m. So what is its corresponding value on y-axis? Yes, it is between 36 and 37, that is 36.5 degrees Celsius. Similarly, the second question, what was the patient's temperature? Sorry, when was the patient's temperature 38.5 degrees Celsius? So where do we find temperature on which axis? Y-axis, that is the vertical line. 38.5 means it is in between 38 and 39. So it is there. So now its corresponding time you see. Yes, it is 12 noon. 12 noon. We will find 38.5 degrees Celsius. Now the C bit. The patient's temperature was the same at 2 times during the period given. What were these 2 times? So the patient's temperature was same at 2 times. In which period it was the same? Come to the graph. Yes, you'll see 1 p.m. we have 36.5 and at 2 p.m. also we have 36.5. So now at what time the temperature is same? 1 p.m. and 2 p.m. Then the D bit. What was the temperature at 1:30 p.m.? How did you arrive at your answer? So 1:30 p.m. See the time on the graph. 1:30 p.m. means it is between 1 p.m. and 2 p.m. That is the middle line will give you 1:30 p.m. So its corresponding value on x-axis, that is on y-axis, is 36.75, which is 36.5. 36 and 37 is there, therefore in middle value it will be 36.5 is the temperature at 1:30 p.m. Next, E bit. During which periods did the patient's temperature showed an upward trend? So means increase in the temperature. You see here from 9 a.m. to 10 a.m. and 10 a.m. to 11 a.m. Similarly 2 p.m. to 3 p.m. we will observe temperature there is an increase, that is upward trend we will find. Is it clear, children, how to answer these questions using the line graph? Yes. Now move on to the second question. The following line graph shows the yearly sales figures for a manufacturing company. What were the sales in the year 2002 and 2006? What were the sales in 2003 and 2005? Compute the difference between the sales in 2002 and 2006. In which year was there the greatest difference between the sales as compared to its previous year? Now observe the graph. So years is expressed on the horizontal line, that is x-axis. 2002, 2003, 2004, 2005 and 2006. 5 consecutive years from 2002 to 2006. And sales in rupees crores. So 2 crores, 4 crores, 6, 8, 10 and 12 crores, which is represented on the vertical line, that is x-axis. So now observe this figure. In 2002 year, what is the sales? Identify its corresponding value on y-axis, it is 4. Therefore it is 4 crores rupees was the sales in the year 2002, and in the year 2003 it is there between 6 and 8, exactly half will give you what it is, 7 crores. So there is an increase from 4 to 7, 3 crores was increased from 2002 to 2003. Again 2004 the sales is 6 crores, which is decreased. 1 crore is fall. Then in the year 2005, the sales is increased to 10 crores. So what is the sales in 2005? It is 10 crore rupees. And in the year 2006, it is 8 crores. So now answer the questions. What were the sales in 2002 and 2006? Yes, 2002 it is 4 crore rupees and 2006 it is rupees 8 crores. What is the difference from 2002 to 2006? It is 8 minus 4. It is 4 crore rupees is the difference in the amounts. Then B bit. What were the sales in the year 2003 and 2005? 2003 we have 7 crores. 2005 we have 10 crores. So 7 crores and 3 crores respectively. C bit. Compute the difference between the sales in 2002 and 2006. Find the difference in the sales from the year 2002 to 2006. As we discussed, it is in 2002 it is 4 crore rupees and in 2006 it is 8 crore rupees. Therefore the difference it is 8 minus 4 it is 4 crore rupees is the difference. Now D bit. In which year was there the greatest difference between the sales as compared to its previous year? So find the differences between the two consecutive years. 2002 and 2003. 2003 it is 7 crores. 2002 it is 4 crores. 7 minus 4 3 crores. 2004 and 2003, 7 minus 6, 1 crore. 2004 and 2005, 10 minus 6 it is 4 crores. 2005 and 2006 it is 10 minus 8, 2 crores. So in which year we will find the highest difference? It is 2005. So like this we will answer the questions from the line graph. Is it clear, children? Yes, so far we discussed the linear graphs or line graphs are given and we answered those questions. Now how to draw the line graph? As I said, we will draw one horizontal line. That horizontal line is taken as x-axis and the vertical line is taken as the y-axis. And we will represent here for this question years on the x-axis and number of days on y-axis and choose the proper scale. Then represent these values, that is the days 8, 10, 5, 12 in the form of points. Then join those points, we will get a line graph. So here, use the tables below. Two questions are there here which we are discussing to draw linear graphs. The number of days a hillside city received snow in different years. Snow in different years. So the number of days a hillside city received snow in different years. So in the year 2003, 8 days. In the year 2004, 10 days. And in the year 2005, 5 days. And in the year 2006, 12 days are there. So this data we should express in the form of a linear graph. A linear graph. Yes. So for that, first draw one vertical line and one horizontal line. Yes. This is vertical line and we will treat this as what? Y-axis. And this we will treat it as what? This line we will treat it as the horizontal line. We will treat this as what? Yes, this will be treated as the x-axis. X-axis, right. Now, on x-axis, we should represent in the form of what? The year. On x-axis, what we will treat as number of days. Number of days. Sorry. On x-axis, we will take the year. So little up you take so that we can write these numbers easily. Yes. So this is x-axis and here we will take years. What will represent our x-axis? Years. So let this is year 2003. 2003 then here we have 2004 at equal intervals, 2005, and here we have 2006. 2006, and our y-axis what do we take? The number of days. Number of days we will take, and see the values 8, 10, 5, 12. So all our smaller values we take each 1 unit length is equals to 2 days. Let this is 2 days and this is 4 days. In between this exactly half will give you what it is 3 days, and here will give you what it is, this is 0 days, and here what it will be, 1 day will be there, then 6 days, then 8 days, 10 days, 12 days. The maximum it is 12 days. Like this represent. Then observe in the table 2003, how many days it is? 8 days. You see this is 2003, straight exactly opposite this. Identify its corresponding value is how much it is? 8 days. So put a point there. So 2003, 8 days there is a snowfall is there. And then in the year 2004, it is 10 days. Yes, this is 2004, exactly opposite to this, 10 days here. Yes, approximately here this is this point. Then in the year 2005, it is 5 days. We have 4 and 6. Middle of this will give you the number 5, that is 5 days. So observe 2005, and here this is 2000. This will give you what? 5, and this will give you what? 2005. So this point will give you 5 days in the year 2005, and in the year 2006 we have 12 days are there. In the year 2006 we have 12 days. Yes, this is 12. You can, if you want, you can represent with the dotted lines, and this is the dotted lines. So on the graph sheet you can do it very clearly. Now this is will represent 12 days in the year 2006. Now join these points first. Yes, this line segment, and then we have one more line segment, and then we have this is the line segment. So let this is. So this will give you the line graph of snowfall in a hillside city in the year 2003, 2004, 2005 and 2006. This is one. So if you want to represent two line graphs also, we can represent on the bar graph, on the graph sheet. Two linear graphs also you can represent it in the similar way. Is it clear, children, how to represent? First draw the horizontal line and vertical line, represent them as the x-axis and y-axis respectively, and choose the proper scale. Then locate the points with respect to this corresponding values. Then join the points, you will get the linear graph. Is it clear, children? Yes. Yes, I hope you understood today what we discussed, introduction to graphs. So the graphs already we have covered in chapter number 5, that is bar graph, double bar graph, pie graph or pie chart or circle graph, and the histogram. So we are going to discuss in this chapter is linear graph. So we have discussed how to draw the linear graph and how to answer the questions on the linear graph. I hope you understand today's concept, and your homework is exercise number 15.1, question number 3, 4, question number 5, the fifth B bit, and question number 6. So thank you very much once again.